Swayam Prabha. Digital India. Educated India.
Welcome friends. In our last class, we discussed some basics about descriptive analytics, where we discussed that how just by simple data visualization, by using tools like Excel, we can see that what are the important characteristics of your data. And for those characteristics, we basically relied on two important things. One, if you recall, is measure of central tendency. We see that we can calculate mean, median, mode, geometric mean, etc. These are different ways of identifying the central tendency of your data. And then we also discuss the variation in your data, that we discussed with the help of range. We discussed about standard deviation, variance, coefficient of variation. All these different things are representing the variation in your data. So, by applying the central tendency and variation, we are able to see many important characteristics of our data. Going further, we know now predictive analytics. Predictive analytics is like what has happened in the past. We are expecting that same thing will go in future also. And many things of decision making in operations management, where you have a particular pattern in your data, and if you identify that pattern, you may go for some kind of a decision making. Descriptive analytics is just about kind of a post-mortem of your historical data, but using that same historical data for a decision making, that is predictive analytics. So, it is one step ahead of the descriptive analytics. So, in this particular session, we are going to discuss about a very popular use case of predictive analytics in operations management. In operations management, as we discussed in the very first class, most of the decisions are taken on the basis of forecasting, that what will be the possible demand of your product in the future. And when I say in future, future may be immediately next future, future may be some period ahead, and future may be many periods ahead. So, there can be different classification of future also. So, predictive analytics can help us in getting some numbers, some data for my future demand, and that is what we are going to discuss in this particular session, where we are primarily in this particular session is going to focus on this time series forecasting. Time series forecasting means you have historical data, these are periods 1, 2, 3, 4, 5. Now, based on these past data, can I predict for 6th period or 7th period? These are my immediate next periods. Can I predict for 8th, 9th period? Slightly far. Or can I predict for 12th period, which is even far? So, all those things are possible with the help of predictive analytics. So, this is the purpose of this particular session, that we are going to discuss one use case of forecasting, but there may be many such cases where you can see that how have you performed in the past, and accordingly you have to use that historical data for your future predictions. So, time series forecasting, as I just mentioned, is use of historical demand data for knowing a particular forecast. If you only talk of forecasting, there are so many different methods through which you can do the forecasting, and one of the most common method which is based on this predictive analytics, that is the time series analysis, where we are using historical data, and this historical data means past data. So, whenever you have any kind of past data, you will see that let us say I am giving you some indication that this is, let us say, period 1, period 2, period 3, period 4, period 5. So, it may appear to you that this data is like this way, and then now you have identified the pattern of this data, that there is some increase in data, some increase in demand happening from one period to another period, and you are expecting that the same pattern will continue for the next period also, and therefore, in the sixth period this will be the possible demand. But actually what happens? Actually, this is what I am saying theoretically, but actually what happens, the demand is moving like this. If you see this green line, the demand is moving like this. It is not a straight line, the red line, it is actually a zigzag line, this green line, and therefore, it is not so easy, that how this zigzag line will move, whether it is like this or it is also possible like this. All these are the possible values which may be there in the sixth period, because there is a random variation which is happening in your demand data. Now, you cannot determine any kind of randomness in your data, but when we are doing the predictive analytics, we divide our data in two components. Out of these past data which is moving like this, you can make a line which is a straight line which is best representing this zigzag movement, and let us say that best line is this line, which is best representing this zigzag movement of the data. Now, in this actual data, now there is two things. One is systemic component and another is random variation. So, systemic component plus random component is making your actual data. So, what we do with the help of predictive analytics, we are basically predicting this systemic component, and then we also know that what is the limits in which this random component may vary. Because of historical knowledge, we know that what is the limit in which this random component will vary, and based on that we may say that okay, this will be the possible forecast in the future, and these are the possibility of the variation. So, that gives us more complete information. So, now when we are going for this systemic component of the demand data, this systemic component also may have some kind of characteristics, and these characteristics are possible in a variety of ways. Systemic component, it may have a straight line like this also. Systemic component may itself have a trend. A systemic component may have some kind of cyclic movement also. So, all these different types of characteristics are possible in your systemic component also. And when you see the systemic component of your demand data, there are level, which we say that the data is moving horizontally, it is parallel to the x axis. Systemic component may have a trend where from one period to another period there is a increase in demand. Now, that increase in demand from one period to another period may be possible in two ways. One is demand is increasing, let us say by plus 10 from one period to another period. Last period the demand was 100, then it becomes 110, then it becomes 120 and 130, like that, that from one period to another period demand is increasing by plus 10. Another way is demand is increasing at the rate of 10%, that is also possible. So, initially if demand is 100, it becomes 110 and then it becomes 121 and then again it becomes 133 and so on. So, now demand is increasing at the rate of 10%. So, you may have your trend either additive trend or multiplicative trend, both these things are possible. This is additive, this is multiplicative. Similarly, seasonality, that in a year demand increases to a high level in a particular season, winter season, rainy season, festival season, and then again demand comes to a lower level. And this increase in seasonality from one cycle to another cycle may be on additive term, may be on multiplicative term. So, based on all these things, you may have your systemic component which may have level, this is if all these are multiplicative, trend is also multiplicative. One more thing, you can call multiplicative activities as ratio also and additive also as linear. So, these are other terms which are popular in literature for additive and multiplicative, linear and ratio. So, if all the components are multiplicative in nature, so level multiplied by trend multiplied by seasonal factor, that will give you your systematic component. If all these are additive, then level plus trend plus seasonal factor will give you your systematic component. Our objective is to determine only the systematic component. Random variations are beyond our control, and if one of them is additive or multiplicative, then appropriately, like in this particular case, we have considered trend as additive and seasonal factor as multiplicative. So, in this way level plus trend multiplied by the seasonal factor will be the formula for calculating your systematic component. Now, here you see that we may have various different combinations, like just we saw you have label, trend, seasonality, and trend can be additive or multiplicative. Seasonality can also be additive and multiplicative. So, in this way you may have a variety of combination of trend and seasonality with level. So, we have made 9 different types of diagrams where you have different combinations of label, trend and seasonality. So, if you see in this picture, the figure number 1, this here neither trend is there nor seasonality is there. So, you see this horizontal line which is parallel to x axis. On y axis we have systematic component and on x axis we have time. So, here you see that systematic component of demand is almost horizontal parallel to the x axis in diagram number 1. In diagram number 2, we have a seasonal component which is linear, but there is no trend. Okay, before we go to diagram 2, let us go to diagram 4 first, which is easier to understand. Now, in the diagram 4, there is no seasonal component, only linear trend is there, and you can see that this is a additive trend. So, a straight line like this is created. Similarly, in diagram number 7, we have multiplicative trend and this is like this. In 1, 4 and 7, there is no seasonal component. Now, coming to diagram number 2, 5 and 8, where you have linear seasonal component, additive seasonal component. So, diagram 2, diagram 5 and diagram 8 are linear seasonal components with no trend, additive trend and multiplicative trend respectively, and the diagrams shape of the systematic components are given here, like this is the shape, this is the shape which you can see in blue color. And similarly, if you see diagram number 3, 6 and 9, diagram number 3, 6 and 9, in this case we have multiplicative trend which is combined with no trend, multiplicative seasonality which is combined with no trend, additive trend and multiplicative trends, and accordingly these 3 diagrams. So, you see that in all we have 9 combinations, or you can say 9 types of characteristics in historic data, and based on these we may have different types of predictive analytics models for handling each of these different cases. One formula may not be possible for all the cases. Depending on the characteristic your historical data has, you need to require a particular algorithm, particular method which is suitable to handle that type of characteristic of data. Now, let us consider the simplest type of example, which is case number 1, no seasonality, no trend, and when there is no seasonality, no trend, you actually go with the simplest type of method, that is moving average method. Now, moving average method is where you have only level in your data, no trend, no seasonality. And in this case, the simple process is that whatever historic data you have, you need to take average of some recent number of data. Some recent data is known as n periods, and with that n period data, you will be able to get the forecast for the next period. Now, obviously, the critic of this system is that for having a better forecast, you need to have data of large number of periods, and that will, if you remember, in our previous class of descriptive analytics, we discussed that average is not a very good indicator and it is very much affected by outliers. So, to minimize the impact of these outliers for any kind of average activity, you need to take a large amount of data. And in this example, I am just showing you that how are we calculating this moving average. For example, we have the weekly sale of a particular product, that is 38,000 tons, 35,000 tons, 77,000 tons and 90,000 tons. These are the weekly sale of April month. So, week 1, week 2, week 3, week 4, you have data 38, 35, 77 and 90. Now, if I have to determine the forecast for first week of these are all April. For May, to determine the forecast for first week of May. Now, if I take the moving average period equals to 1, if I take moving average period equals to 1, the forecast for first week of May will be 90 if n is equals to 1. Now, if I want to again see whether my forecast is correct, can we have a better forecast? The answer is yes. You can have a better forecast, but you need to increase the period of weighting moving average, increase from n equals to 1 to n equals to 2, take the average of most recent 2 periods. You can further improve your forecast. Now, take n equals to 3, and this n equals to 3 will be for most recent 3 periods W2, W3, W4, 35 plus 77 plus 90 by 3. And in my slide, I have already solved that if I take the moving average period equals to 4, this will be the 38, 35, 77 plus 90 by 4, and you get the answer equals to 60. So, you see that as I am increasing the period of moving average, my estimations are also changing, and therefore, for having a better forecast, you should have more number of periods in my historical data. For if I use n equals to 5 in this case, if I use n equals to 5, I will be requiring March week 4 data also. Only when I have March week 4 data, then I will be able to calculate forecast using n equals to 5. So, this is moving average method, and moving average method has the limitation of more number of data is needed. Moving average requires and it is very much sensitive to any kind of outlier also, and therefore, sometime people say that okay, your demand should be more dependent on the recent data. In this case, when I am taking n equals to 4, I am giving equal weightage to all the past periods, but it may not be desirable to give equal weightage to all the past periods. So, we go therefore on this weighted moving average method. In the weighted moving average method, we may have same n equals to 4, but here what we do that this is week 1, week 2, week 3, week 4 of April. So, if I am looking for forecast for first week of May, in this case earlier it was simply the sigma W I equals to 1 to 4 by 4, but now I will have W 4 and a weight alpha 4. plus W3 alpha 3 plus W2 alpha 2 plus W1 alpha 1. These are the weights alpha 4, alpha 3, alpha 2, alpha 1, and I have taken these weights in such a manner that alpha 4 is higher or equal to alpha 3, higher than equal to alpha 2, higher than equal to alpha 1, and alpha 4, alpha 3, alpha 2 plus alpha 1 equals to 1 also. So, these are the two conditions where we get liberty, flexibility to give more weightage to the most recent period, and as we are moving away from the most recent period, these weights can reduce in a particular manner. So, you will not be affected by a particular outlier. If there is a period which is slightly abnormal in your demand data, historic demand data, you can reduce the weightage of that period by choosing a particular suitable weight. So, here you see that these types of weight etcetera are possible for our demand data of the previous case, and you can use the same data for these weights and see that what is your new forecast. So, after these moving average methods, where we have limitation that we need huge amount of historic data and we are not able to set the importance of our historic data, because there may be outliers which may affect our decision making in a big way because of a static method of decision making. It will have a limited use in the predictive analytics, where we are looking for regular calculations, we are getting more real time data. So, how to use that real time data for improved forecasting purpose? Then we have another category of methods which are part of exponential smoothing methods. In these exponential smoothing methods, we may be using different types of smoothing constants, alpha, beta, gamma, etc. As you may recall that I discussed that in our historic data, we are having two important components. We actually have our data like this, and if I smooth this data, this becomes my level diagram. The dotted line is representing the level and the zigzag line, the continuous line, is the actual data. So, there are fluctuations like these. Now, you see my diagram, the diagram is moving like this, and if I compress these lines in such a manner that I smooth these lines, so it will then become a straight line, which is represented by, let me use a different color so that you can understand this line. This is that line which is result of the smoothing impact on the actual demand data. This is known as exponential smoothing method. Now, smoothing methods will give you the flexibility to use different types of methods, different types of formula rather, depending upon the 9 different models which we discussed in the beginning of this particular session. You may have examples like when there is no trend, no seasonality. We will be discussing in our next class that how different types of exponential smoothing methods are possible, with the starting of a very simple case of exponential smoothing where there will be no trend, no seasonality, and slowly we can build complexity that you may have trend also, you may have seasonality also, additive, multiplicative trend, multiplicative seasonality, and that will give you the power of analytics, that how different types of trend of your data, different types of characteristic of data can be used for modeling the predictive analytics forecasting systems. So, with this we come to end of this particular session, and we will be discussing about various types of exponential methods in our next session. Thank you very much.